Okay, so continuing on from the previous video that I did, today I'm going to be doing some examples on the simple harmonic motion. Now, what you got to remember from the last video really is that simple harmonic motion can be described in three ways. So we have the first most obvious equation where you have x is equal to a sine nt plus alpha, right? So that's straightforward simple harmonic motion. But when you differentiate it, you end up getting velocity squared is equal to n squared, a squared minus x squared, right? So that's the second equation. And then third one is the acceleration is minus n squared x. Showing that any three of them is true is equivalent to saying the motion is simple harmonic motion, right? So I don't need to end up saying x is equal to a sine nt plus alpha, say this is indeed simple harmonic motion. If I show that any three of these are true for any particular problem, then that's the same as me proving the first one. Okay, now if you were to memorize anything, if you were to memorize any of these equations, I strongly suggest you memorize the first one and the third one. Okay, the reason is that the second one you should be able to derive it from well, either one of them, right? But it turns out it's easier to do from acceleration. Now, if you remember from one of my previous videos, acceleration can be written as d half v squared dx, right? So if that's equal to minus n squared x, so this is given, right? So if acceleration is minus n squared x, to get velocity squared, right, what you need to do is integrate both sides. So I'm going to move the dx onto this side, right, and then integrate it. So integral of d half v squared is just simply half v squared, and this side, when we integrate minus n squared x, right, so remember x is a variable in this case, I end up getting minus n squared x squared on 2, right? So you should be seeing, hey, I'm almost getting this thing over here, right? And then obviously I had to go a plus c. Now it turns out, like if I multiply by 2, I will end up getting velocity squared is equal to 2c minus n squared x squared, right? And if I take n squared out of this equation, I will end up getting 2c on n squared inside minus x squared, right? So basically what I'm trying to say is that this constant term 2c on n squared is equal to my a squared. Okay, so yeah, so basically memorize the first and the last equation, right, and be able to derive the second one, right, because this is probably the ugliest out of the three equations. Okay, anyway, so I'm going to be doing three solid examples. The first one to get me so this, they say that it is simple harmonic motion. So what I need to find is the period, the amplitude, so the amplitude of the motion, right, and the maximum speed. In the second question, I need to show that this is indeed simple harmonic motion, right? So that's all I'm going to be showing in that one. And third one, same thing. I need to show that the movement is simple harmonic motion. Okay, let's get started. All right. So the first question I have is they've given me the start, like initial conditions, right? So when t equals 0, x equals 0, and velocity is equal to 2. Okay, so what I really need to find is to find in my equation, I need what they're really asking me to find is to find a and maybe even alpha. Okay, so alpha isn't too important, but let's get started. Okay, so they're saying at x equals 0, at t equals 0, x equals 0, right? Right, so I'm going to sub this into my equation. So I will end up getting 0 is equal to a sine. Now my nt, because t is 0, I will just simply end up getting a sine alpha. Okay, so what I can do is I can divide through by a on both sides, and I will get still equal to 0. Therefore, alpha has to be, so alpha is sine inverse of 0, which is 0. Now for these questions, you only worry about alpha when it's between 0 and 90 degrees, right? So you don't worry about any of the other angles. Okay, so that's how we got a. Now let's alpha. Now let's work on trying to get trying to get a, for example. So for this one, I'm going to quote the second equation where I say velocity squared is equal to n squared a squared minus x squared. There's actually one part that I missed, I forgot to tell you. So in this question, they actually told me that x double dot was equal to minus 9x. Okay, so that's the part that I forgot to tell you. So from here in itself, that's minus n squared, right? So from there, I should be able to say n is equal to 3. All right, okay, so n will relate to period, but we'll talk about that in a bit. So, right, so now I have velocity squared, which is 2, right? So it's 2, so I will end up getting 4. 2 squared is 4. N squared is 9. A squared, we still don't know. Minus x squared. So x in this case was 0, so minus 0. Okay, so in the end, I will end up getting a is equal to square root of 4 on 9, which is 2 on 3. And again, we only worry about just the positive one because we're talking about the amplitude, right? So amplitude is always a positive quantity. Right, okay, and so for now, that's all the data that we need. So we got a, which is 2 on 3, n, which is 3, and we got alpha. Okay, so we got all the data that we need to calculate. Period, amplitude, so amplitude we already got, and the maximum speed. Okay, to find period, I think I told you this in the last video, what you really need to do is this term over here has to be equal to 2 pi. So I'm going to say n capital T, now capital T stands for period, has to be equal to 2 pi. Now in our case, n was 3, right? So let me just write 3t. So my period is going to be equal to 2 pi on 3, right? Easy. The second one, the maximum velocity, so sorry, the maximum speed. So if I go back to my original equations, right, maximum velocity, now if you differentiate velocity, you get acceleration, right? If you get acceleration, in terms of any maximum minimum question, what do you need to do to find a maximum? You need to find the derivative, the differentiation is equal to 0. So in other words, you need to see when the acceleration is equal to 0. And that usually happens about the center of motion, right? So in this case, when x is equal to 0, right? So all we really need to do is, if you look at this equation, we need to set x equal to 0 to find the maximum velocity squared, and therefore we should be able to get speed. So in our question, we will have to say velocity squared is equal to n squared, which is 9, times a squared, which is 4 on 9, right? So remember, x is 0, that's all we need to do. And so we will get, so velocity squared equals 4, velocity is equal to plus or minus 2, but all we care about is speed, which is velocity, absolute value of velocity, so it's equal to 2. Right, so that's our maximum speed. Okay, yeah, so remember all I did was set the differentiation of velocity, which is acceleration, equal to 0. Okay, so that's all I did. So this happens at the center of motion with simple harmonic motion, all right? So at the center of motion, we have our maximum speed of 2. Okay, now the second question. Velocity squared is equal to that. 300, okay. Is equal to 300 plus 100x, 100x minus 25x squared. Okay, let me just make sure that is actually the question. Right, okay, so there we go. So I need to show that this is simple harmonic motion. Now what I really need to prove is that it takes the form n squared a squared minus x squared. Okay, so a squared minus x squared. So what I'm going to do is I'm going to try and factorize this one. Okay, velocity squared is equal to, so I'm going to take I need to take any constant term of x squared out, right? So if you look at this one and take that out, so I'm going to take 25 out. Okay, so in this one I will end up with 12, and then this part, right? So see how it's a minus x squared? right? So what I'm going to do is I'm going to write this as minus in brackets x squared, right? So this would have been a 4 when I take out the 25, but it's going to be a minus 4x. Okay, so minus minus gives you a plus. That's why that happens. Okay, the next step that I'm going to be doing is I'm going to be completing the square. So I will go 12 minus in brackets x squared minus 4x plus x squared minus 4x plus 4. Right, so I introduce this 4, so I need to get rid of it. So it's a minus 4 that I introduce, so I need to go a plus 4. Okay, so I hope that makes sense. Minus 4 plus 4, so I'm adding just 0. Okay, so so this will end up being 25, and over here will be 16. And now I'm going to factorize this because I completed the square. I should get a perfect square, so that will be x minus 2 squared. Okay, so now if you look at this equation that we have, right? So if you look at the equation, n squared is 25. So n is equal to 25. N is equal to 5. Okay, so if you want to calculate period, it's just the period is going to be 2 pi on 5. Okay, the amplitude is going to be my amplitude squared is 16. So amplitude in this case is 4. My center of motion, so that's what's so different about the questions that we've done so far. The center of motion is 2. Okay, so this is indeed simple harmonic motion. So if this is really confusing you, I can just substitute dummy variable, right? So I can say y is equal to x minus 2, right? So in this case, velocity squared is equal to 5 squared times 4 squared minus y squared, right? So that's y is simply x shifted 2 to the right. Okay, so y is simply x shifted 2 to the right. So like you can see, this is just simple harmonic motion. The next question I'll be doing in my next videos because we run out of time. But thanks for listening, and if you have any questions, let me know. I'll talk to you soon.